In this lecture, you will understand the angle of incident, the angle of reflection, and the angle of transmission in both normal and oblique incident. You will also understand Snell's law and refraction. My name is Joe, and I help people understand ultrasound physics and pass the SPI exam. What is the angle of incident? Some people mistakenly think that the angle of incident is the angle formed between the interface and the sound beam or the sound wave direction. In fact, the angle formed between the sound beam and the interface is not the same as the angle of incident. So what is the angle of incident? The line which is perpendicular to the interface, we call it a normal line. And the angle of incident is the angle formed between the normal line and the sound beam. And we call this theta 1. The angle of transmission is the angle formed between the transmitted sound beam and the normal line, and we call it theta 2. The angle of reflection is the angle formed between the reflected sound beam and the normal line, and we call it theta 3. So again, we have theta 1, which is the angle of incident, which is the angle between the sound beam and the normal line, and we have theta 2, which is the angle of transmission, and it's the angle between the transmitted sound beam and the normal line, and we have theta 3, the angle of reflection, and it's the angle between the reflected sound beam and the normal line. Now, what is the normal incident? If the sound beam perpendicular to the interface, we call this a normal incident. That means that the angle forming between the sound beam and the interface is 90 degrees. However, the angle of incident will equal to 0 degree. Why 0 degree? Because both the normal line and the sound beam are perpendicular to the interface. That means that the normal line and the sound beam will be parallel to each other, and the angle formed between the normal line and the sound beam will equal to 0 degree. Another name we use for a 90 degree angle is orthogonal and right angle. If the sound beam is not perpendicular to the interface, we call this an oblique incident. In both normal and oblique incident, the angle of reflection always equal to the angle of incident. That means that theta 3 will equal to theta 1. Theta 3 is the angle of reflection and theta 1 is the angle of incident. So in oblique incident, the angle of incident will equal to the angle of reflection, and also in the normal incident, the angle of incident will equal to the angle of reflection. In normal incident, we know that the angle of incident is equal to 0, so also the angle of reflection will equal to 0. That means that the angle of reflection will also be perpendicular or 90 degree with the interface. Now, what about the angle of transmission? In normal incident, the angle of transmission always equal to the angle of incident. That means theta 1 will equal to theta 2 will equal to 0 degree. So in normal incident, the angle of reflection and the angle of transmission always equal to 0 degree. In oblique incident, the angle of transmission sometimes equal to the angle of incident and sometimes is more than the angle of incident, and sometimes it can be less than the angle of incident. When the angle of transmission is different than the angle of incident, we call this refraction. Refraction means that the angle of transmission is not equal to the angle of the incident. So as we see here, that refraction happens only on the oblique incident and it cannot happen on the normal incident. Now we'll use Snell's law to understand why in normal incident refraction will never happen. In other words, why in normal incident angle of transmission is always equal to the angle of incident. We will also use Snell's law to understand an oblique incident when the angle of transmission equal to the angle of incident, and when it's more than the angle of incident, and when it's less than the angle of incident. Snell's law states that sine theta t divided by sine theta I equal to ct divided by ci. Theta t is the angle of transmission, and theta I is the angle of incident. Ct is the propagation speed in the medium of the transmission, and Ci is the propagation speed in the medium of the incident. We can rewrite Snell's law in another form in order to be more easy to calculate the angle of the transmission. So we can say that sine theta t equal to sine theta I multiplied by ct divided by ci. And we can use this to determine the angle of transmission in both the oblique incident and the normal incident. So we'll start first with the oblique incident. We know that in oblique incident, sometimes the angle of transmission equal to the angle of incident, and sometimes the angle of transmission is less than the angle of incident, and sometimes the angle of transmission will be more than the angle of incident. But when this happens, this part of the equation is what determines the angle of transmission, whether it will be equal to the angle of incident or less than the angle of incident or more than the angle of incident. So the first case, we have the angle of transmission equal to the angle of incident. This happens when the propagation speed of the two mediums are equal to each other. That means that the propagation speed of the incident medium equal to the propagation speed of the transmitted medium. So why this happen? This happens because when we divide the propagation speed of the transmission by the propagation speed of the incident, and because both of them have the same value, the result will equal to 1. If we take this part and put 1 instead, the result will be sine theta t equal to sine theta I multiplied by 1. When we multiply any number by 1, the result will equal the same original value. So that means that sine theta t will equal to sine theta I, and that means that theta t, which is the angle of transmission, will equal to theta I, which is the angle of the incident, and that means that there is no refraction happening, and the sound beam will go straight like that. The second case, we have that the angle of transmission is less than the angle of incident. Again, we'll use this part of the equation. If we have the propagation speed of the transmission less than the propagation speed of the incident, when we divide ct over ci, the result will be less than 1. When we multiply any number by another number which is less than 1, the result will be less than the original value. So when we multiply sine theta I by a number which is less than 1, the result will be less than the original value. So that means that sine theta t will be less than sine theta I, and that means that theta t, which is the angle of the transmission, will be less than theta I, which is the angle of the incident. And that means that refraction will happen because the sound beam, instead of going in a straight line, it will bend toward the normal line. The third case that we have with oblique incident is the angle of transmission is more than the angle of incident. And this happens when the propagation speed in the transmission medium more than the propagation speed in the incident medium. Again, we'll use this part of the equation to understand why this happened. So when we divide ct by ci, and because ct is more than ci, the result will be more than 1. And when we multiply any number by any number which is more than 1, the result will be bigger than the original value. And that means that sine theta t will be more than sine theta I. So again, in oblique incident, if the propagation speed of the two medium are equal, the angle of incident will be equal to the angle of transmission, no refraction will happen. And if the propagation speed in the medium of the transmission less than the propagation speed in the medium of the incident, the angle of transmission will be less than the angle of incident and refraction will happen. And if the propagation speed in the medium of transmission more than the propagation speed in the medium of the incident, the angle of transmission will be more than the angle of the incident and refraction is happening. So refraction happen in oblique incident only if we have propagation speed difference between the two medium. In normal incident, we know that there is no refraction, and we know that the angle of the incident equal to the angle of transmission, and both of them are equal to 0 degree, and both of them are perpendicular to the interface. But why this happen? This happen because we have an incident angle equal to 0, and we know that sine 0 equal to 0. So if we take sine theta I and put 0 instead, the equation will be sine theta t equal to 0 multiplied by ct divided by ci. Any number multiplied by 0, the result will be 0. So that means that sine theta t, sine the angle of transmission, will equal to 0, and that means that the angle of transmission will also equal to 0. From here we can understand that refraction only happen in oblique incident, and in order for refraction to happen, we need to have a difference in the propagation speed. If the propagation speed is more in the transmission medium, the angle of transmission will be bigger. If the propagation speed in the medium of transmission is less than propagation speed on the medium of the incident, the angle of transmission will be less. In the next lecture, you will understand how to calculate the intensity reflected coefficient in both normal incident and oblique incident. Thank you for watching, and see you in the next video.